Open your book to page 98. Today's lesson is to find the exact values of the trigonometric function. So you need to know the position of the angle and know how to draw triangle and spatial triangles, and then you have to be able to figure out the value. So let's go over some examples of how to evaluate. So let's go to example 1. So on page 99, on example 1, okay, it says A, you want to find the sine of 90 degrees. Now, this is a unit circle, means the radius of 1. Okay, so what happened is, so sine of 90, so first you need to find the position. So 90 is right over here. So this is 90 degrees, right? So this is right over here. Now remember, this is unit circle, so radius is 1. Okay, so in this case, the height is 1, and the radius is also 1. So this will equal to 1. Okay, so you can, because there's no triangle. This is called a quadrantal angle. Quadrantal angle means it's going to be at one of those 4 positions. So there's no triangle. But so you need to go and just figure out the ratios. Okay, so again, sine is the vertical, so vertical is 1, and hypotenuse coincide with the vertical, so it's also 1. So therefore it's 1. Okay. And now let's go to B. For example 1b, you have cosine of pi. So you need to know that the pi is right over here. So you're going to get this right over here. So the length at this position is -1. Right? Remember, sine and cosine, you have to watch the positive negative. So the length of the horizontal is -1, and the length of the radius, remember radius is always positive, right? Will be 1, so therefore it's equal to -1. Okay, now let's go to C. So you got to be able to figure out the position, and you have to be able to know if it's vertical or horizontal. So C, you're looking for tangent of -2 pi. So you can use pen to draw a circle, and you can use pencil to use a circle over and over, right? like what I'm doing, right? So start over here. So -2 pi means you're going this way, so you end up right over here. Okay, so you end up right over here. So that's the position. So in this case, the slope of that is equal to 0. Remember, tangent is slope, right? So once you get the point over here, you draw your reference line and look at that. So again, this is for vertical, this is for horizontal, this is a slope. So slope of that is equal to 0. Okay, and so that is your answer for tangent of -2 pi. Now let's go to D. You're looking for cotangent of -180 degrees. So first we need to do is figure out the tangent of that. Okay, so -180 is right over here. Right, that's right over here, so you saw that. So again, let's go and figure out the tangent first. So the tangent of -180 degrees is equal to 0, right? Now cotangent is 1 over that. So this will equal to 1 over 0. Okay? So this is undefined. You cannot do that. So in this case, it's undefined. So answer for cotangent of -180 is undefined. Okay, because tangent of -180, the slope is 0, and so 1 over 0 is cannot, so it's undefined. So that's how you do the quadrantal angles. Now let's go to page 100. Now you're going to be able to figure out exact value of all the other angles. So the handout that I give you over here, that's for you to keep. You can feel free to write any notes on that. So you need to know that anything have a denominator of 6 is kind of on a lower position. See over here? So this is over 6 over 6. So you're kind of close to the horizontal. Anything over 3, I see pi over 3, 2 pi over 3, is kind of closer to the vertical. Anything over 4 is kind of halfway in between. Another thing you need to do is you need to know the count around the circle. So this way, so notice if you look at the clock, right, each number on the clock is like the pi over 6. So from here, you go pi over 6, 2 pi over 6, that's how you get pi over 3. Right? So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, and so forth. Okay? Now pi over 3 is like 2 numbers on the clock. So again, you need to know how to count that, right? So this is 1 pi over 3, 2 pi over 3, 3 pi over 3, okay? Then you got 4 pi over 3, 5 pi over 3, 6 pi over 3. So you need to know how to count around the circle to figure out where you need to go. Pi over 4 is halfway in between. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay? So you need to know how to count around the circle. So that way you need to know where things at. And then after that, you draw your spatial triangle, and then you use your spatial triangle. Use this handout, the 30-60 spatial triangle, 45-45 triangle to get exact value. Okay? So you need to be able to do that, because on the test, you're not allowed to use calculator. Okay? And besides, the calculator does not give you the exact value. It will give you a decimal. Okay? It will give you the irrational decimal. Okay? So you need to know how to get exact value. So when I say looking for exact value means using the square root, not the irrational decimal, right, number. Okay? Okay, so let's go over some examples how to do these. So let's go to page 101, and let's go and do some examples. So page 101, example 2a. You're looking for secant of 5 pi over 4. So first you want to do is figure out where that thing is. Okay? So this is 1 pi over 4, right? So again, you need to know the count. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So it's right over here. So you can just draw that and draw your triangle. So this is going to be a 45-45 spatial triangle. And so what you want to do is you want to use one of the ratio, right? So you can just use 1, 1, square root of 2, right? So first get a number, then after you have to worry about positive or negative. So negative 1 and negative 1, right? Okay. So secant came from cosine, right? So for cosine would be this over this, right? Negative 1 over square root of 2. But secant is the reciprocal of that. So again, first you think about cosine, right? So cosine of 5 pi over 4 is equal to this, equal to negative 1 over square root of 2. Therefore, the secant of that will equal to square root of 2 over negative 1. So it would be negative that. So it would be negative square root of 2. So that's how you need to do this kind of problem. So again, first you need to locate the angle, draw the triangle, just like what we did before, right? Then after that, you go ahead and get 3 sides, and then you write the ratio. Now, except you don't have to write all 6. Right now, all you need to do is 1. So again, so it's same as what you've been doing before. Same thing, right? You get your triangle, get all 3 sides, and then write your ratio. Okay. Except now all these would be spatial triangles. Okay. Okay, let's go to B. Tangent of negative 45 degrees. So you can remember the key is get your angle, right? Negative 45 degrees is right over here, right? You're going opposite direction, right? So that's negative 45 degrees. So draw your triangle. Again, this is your 45 special triangle, right? So it'd be 1, 1, square root of 2, right? So get your number first, then you have to watch the positive, negative. So this is positive, this is negative. So now you can go and use your function now. So tangent is vertical over horizontal, so it'd be negative 1 over 1, so therefore it's negative 1. Okay, so again, it's negative 1 over 1, so it's equal to negative 1. So again, we're not doing anything new. Okay, the only thing you have to do is you have to be able to locate the angle, locate the position of the angle, and draw a triangle, and get 3 sides, and write your ratio. Okay, so let's keep going. Let's do few more examples. C, you have sine of 135 degrees. Okay, so here's 0, 90 degrees. Here's your 180 degrees. So 135 is right over here. Again, it's 45 degree special triangle. Right, so that is your 135 degrees. Okay, so you can write your ratio. So it's 1, 1, square root of 2. And this is a negative, so put over here. So sine of 135 would be equal to 1 over square root of 2. And if you simplify, you get square root of 2 over 2. Okay, so again, this is how you figure out exact value. Okay, let's go to example D. So page 101, example 2D. You have cosine of 9 pi over 4. Okay, so again, start with 0. So there's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, 8, 9. So here's your 9 pi over 4. So it's 45 degree triangle. So again, it's 1, 1, square root of 2. So cosine is horizontal over hypotenuse. So equal to 1 over square root of 2. So equal to square root of 2 over 2. Now, you can get answer directly if you use the square root of 2 over 2, like this kind, right? But I kind of like to use the 1, 1 square root of 2, and I can simplify there. So again, either way, you can use any one of the special triangle, right? The values, as long as you have the correct ratio. So make sure you know your special triangles, okay? And all the problems are just like that, okay? Now, next thing you have to do is you have to find a reference angle. So another term that you're going to get used to is on page 103. In the middle of the page 103, you have the reference triangle, and from there you have the reference angle. Okay, so look at that yellow box. So reference triangle, the reference triangle is used to calculate all the the value, like what you did over here. Okay. So let's go over some example. What do they mean by the reference triangle and the reference angle? So reference triangle is the angle that they give you, and you just draw the triangle based on the angle. Okay, so let's go to example 4 on page 104. So let's go to example 4 and do A. So you got theta equal to 330 degrees. So it says sketch the reference triangle. So that means you're looking for the angle and you want to draw the triangle based on that. So 330, so here's your 0, 90, 180, 270, and so you have to go 60 more, so it'll be right over here. Okay. Again, if you look at the clock, each number on the clock is 30 degrees. So if you're over here, right, so over here is 6 o'clock, so you go 5 o'clock, would be the 300. So at 4 o'clock position, that's where you get the 330. Okay, and so that's your angle, and then you draw the triangle based on that. You always draw up and down, never go sideways, always go up and down. So the triangle that you draw, that is called a reference triangle. Okay? And the angle that inside here is called it's the alpha. This is called your reference angle, and it's always positive. So this would be, in this case, this would be equal to 30. So your reference angle is 30 degrees. So again, this is your 30-60 spatial triangle. So this would be 1, 2, square root of 3. Okay, again, that's your 30-60 spatial triangle. And you have to watch the positive, negative, so it would be negative. So in this case, so that's how you draw your triangle. Now this one, they don't ask you for the value. They just ask you to draw your triangle. That's all they want you to do. Okay. So now we can go and use that same as what we did earlier to find the exact value. So let's go to example 5. So let's go to page 105. And let's look at example 5. And start with A. You're looking for cosine of 2 pi over 3. So first, you need to go and draw the angle. So 2 pi over 3. So here's your 1 pi over 3, 2 pi over 3. So your angle is going to be right over here. So your reference angle is right over here. That's going to be your 60 degrees. Okay, but since they use radian, you want to use a radian. So this is 2 pi over 3. So your alpha right over here. So this right over here. So your alpha equal to pi over 3. Okay, 60. So this is 60 degrees. So it's pi over 3. Okay, or you can subtract from, here's your pi. So pi minus 2 pi over 3 give you 1 pi over 3. Okay, so you got to get used to figure out the angles. And to figure that out, again, that's your 30-60 spatial triangle. So that's your 1, 2, square root of 3. And this is negative. So cosine is horizontal over the hypotenuse. So it would be negative 1 over 2. Okay. And that's your answer. Okay, let's go to example B. Yeah, tangent of 315 degrees. So again, first you have to locate your triangle. Okay, so 315, so again, here's your 0, 90 degrees, 180, 270, and you need to get 45 more, so it's going to be right over here. So that's your alpha is 45 degrees. So your reference angle is 45 degrees. So in this case, you're going to get 1 square root of 2. And so the positive, negative, so this positive, this is negative. So tangent is vertical over horizontal. So it's negative 1 over 1, so equal to negative 1. Okay? Okay, let's go to C. Yeah, sine of negative 3 pi over 4. So you can get your triangle. So you have to go backward now. So that's, again, anything over 4 is halfway, right? So negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. So it's going to be right over here. So that's your angle. Then you have to draw your triangle. And you have to get your reference angle. So this is pi over 4, right? 45 degrees. So again, that's going to be your negative 1, square root of 2. So now the sine is vertical. So sine is vertical over hypotenuse. So you go to negative 1 over square root of 2. So equal to negative square root of 2 over 2. Okay. Okay, now let's go to D. Cotangent of 300 degrees. So again, first let's locate our angle. So it's 0, 90 degrees, 180. Now, you don't have to label the degrees over here, okay? I'm just label so you can follow, so you can easier to count the number around the clock or around the circle. So here's your 270, so you need to get 30 more, so it's going to be right over here, right? Each number is 30 on the clock, right? So you draw your triangle, so that's your 60 degrees over here. So you're going to get 1, 2, square root of 3, and this is negative. Okay, so cosine, so the cotangent Cotangent has to do with the slope, right? So tangent is y over the x, so it's this over that. Cotangent is reversed, so cotangent is 1 over negative square root of 3. Again, tangent is sine over cosine, cotangent is cosine over sine. So cotangent is horizontal over the vertical. So this is equal to negative square root of 3 over 3. And that is your answer. Okay, so that's how you do this kind of problem. Okay, now let's go to example 6. Let's go and stop over here. So let's go and do some practice.